Click the bell icon to get latest videos from Ekeeda.
Hello friends, in today's video, we are going to see what are the various requirements that op-amp required to be fulfilled to be used as a comparator. So let's begin with the topic. As we know, op-amp can be used for a number of applications. It can be used as an operational amplifier. It can be used to perform number of algebraic functions like addition, subtraction, multiplication, integration, differentiation, and many more. But these applications are used when op-amp is used in closed loop configuration. That means when output is feedback to the input through a proper feedback network. But when the op-amp is used in the open loop configuration, it can be used as a comparator. The open loop configuration of op-amp having application of comparator, like it can be used as a zero crossing detector, it can be used as a Smith trigger, it can be used as a window detector, and many more. But to use op-amp as a comparator, the op-amp requires to satisfy certain condition, because we know that in case of op-amp, when output changes slightly positive or slightly negative, then the output reaches either to positive or negative saturation, because the gain of op-amp in open loop configuration is very high. Ideally, it is infinite. So even if there is a small change in the differential input voltage, then output of op-amp can be reached either to positive or negative saturation. And because of this reason, the op-amp in open loop configuration is not used for linear application. One of the application of open loop configuration is nothing but comparator. Comparator, as its name indicates, it is used to compare two input signal. So basically the comparator having two input terminal and one output terminal and no feedback signal. So the input terminal can having two input signal, that means Vin, the signal which is to be compared, and the reference voltage which is known to the user. Depending upon to which terminal the Vin is applied, the comparator can be of inverting or non-inverting comparator. If the input is applied to the inverting terminal, then it is called as inverting comparator, and if the input is applied to the non-inverting terminal, then it is called as non-inverting comparator. But to use op-amp as a comparator, the circuit of op-amp required to satisfy certain conditions, and the requirements are: the first requirement is the output must change rapidly. In order to change the output very rapidly, the circuit or the op-amp having high bandwidth, so that the speed of operation can be improved. The second requirement is large voltage gain for improving speed. If the gain of op-amp is very high, then hysteresis is get reduced, and that reduction in the hysteresis can be used for improving speed of operation of the op-amp. The next requirement for op-amp to use as a comparator is high CMRR. CMRR is nothing but common mode rejection ratio. Common mode is basically a signal which is present at both the input terminal of op-amp, or we can say the noise signal which is commonly present at the input terminal of op-amp is called as common mode signal. The common mode rejection ratio defines ability of the op-amp to remove this common mode signal, because even if there is a small signal present at the input terminal of op-amp, the op-amp can provide output. If the op-amp is used in open loop configuration, then small signal present at the input terminal can causes op-amp output to reach either to positive or negative saturation level. That will change the output of the circuit. So if the value of CMRR is high, then it indicates that the op-amp having high ability to reject the common mode signal. Therefore, if we want to use op-amp as a comparator, then the op-amp required to have a high CMRR. Ideally, the value of CMRR should be infinite, but practically it should be as high as possible. The next requirement for op-amp as a comparator is small input offset voltage and input offset current. Ideally, if there is no input signal, the output of the op-amp should be zero, but practically it is not possible. Some amount of voltage is always present at the output even if the input signal is not applied. Therefore, we need to apply some voltage at the input terminal so that the output of the op-amp gate reduces to zero. So the value of differential input voltage that is applied to the input terminals of the op-amp is called as input offset voltage. This value of input offset voltage should be as small as possible. The second parameter that we need to consider for op-amp to use as a comparator is nothing but input offset current. The input offset current is basically due to the current flowing through the inverting and non-inverting terminal of the op-amp. It is basically defined as the algebraic difference between the current flowing through inverting and non-inverting terminal of op-amp. Therefore, we can say IB is equals to IB1 minus IB2. This value of algebraic difference should be as small as possible. Ideally, it should be 0, but practically it should be as small as possible, because if the input offset current present at the input terminal, then it can provide certain amount of signal at the output. So even if there is no input signal, so the value of input offset voltage as well as value of input offset current should be as small as possible if we want to use op-amp in open loop configuration as a comparator. The last requirement to use op-amp as a comparator is nothing but the parameters of op-amp should not vary with respect to temperature. The temperature variation can cause variation in the output of the op-amp if there is any change in the parameters of the op-amp. So the compensation is supposed to be provided to the op-amp internally so that we can use the op-amp as a comparator. So these are the certain requirements for op-amp to use as a comparator in open loop configuration. So I hope you understand this topic. So thank you very much for watching this video. Stay tuned to Ekeeda, subscribe Ekeeda. Thank you.